January 20th, 2017, Baz, this might be a good idea for a new video. Reasons why Venus is older than the Earth in GTSM. Drew a few diagrams here, I'll read it out to you. Venus has no magnetic field, and it has a very weak magnetic field. If it has any type of magnetism, it's very, very weak. That signals that the mantle does not move with a dynamic motion as Earth's mantle and core. Remember, these two objects are about the same size. So to think if one of them has a large magnetic field with lots of mantle motion against the iron core, then chances are it's very young. It's still hot in the center. But if you have no magnetic field and there's nothing to move around in there, there's nothing to produce the magnetic field. So chances are it's way, way older than the Earth. And that's something that really bothers me about establishment, is that they assume so much that they fail to look at them with the perspective that need to be looked at. They just say, well, that's the same age as Earth, end of story. How the hell to get like that, we don't know. Clearly it's older, because it also has no volcanic activity. The astronomers and astrophysicists and the establishment in general, they're like, why aren't there any volcanoes on it if it's same size and the same age as Earth? Where'd all the volcanoes go? Where are all the earthquakes? Where's all the plate tectonics? It doesn't exist on this object because it's old. It's completely solidified almost. I mean, the crust is thickened considerably. I'll go ahead and go over that. And that's overviewed in the ossification principle, which means, quote, the crust of an old star thickens as the heat escapes and the solidification of the interior deepens. It basically means if you have a very thin Earth-like crust and it ages, the crust gets thicker and thicker and thicker on the surface, which means as well it would block any type of heat coming in, and as it deepens, the liquid interior solidifies. So there's no way for it to be to have volcanic activity or plate tectonics, because plate tectonics is misinterpreted as gravitational collapse, which means the crust is crushing itself. But if it isn't crushing itself anymore because the crust is too thick, it can support all the weight now, there's no way there's going to be any earthquakes. And I drew a little diagram here. If you have a Venus-like crust where it's about 2,000 kilometers thick, it's a lot different than Earth, which is only about 5 kilometers and 200 kilometers thick. So, and then you have the intermediate stage where the crust would only be about 1,000 kilometers thick. So you have Earth as it cools and the crust solidifies and deepens, it'll become like Venus, which means Venus is very, very, very old. And this is predicted that when we find Earth-like objects, we're going to find some of them with very sporadic volcanic activity and some that don't have any volcanic activity at all. So that's a prediction as per the ossification principle. Another reason why Venus is much older than the Earth is that it has no life. This is a new idea here. It's beyond the 1950s Goldilocks zone hypothesis. There's a timeline with which a star can host life. There's a window of opportunity between, this is a general estimate, between the star being born in 3 billion years, when it's a gas giant type radiant plasmatic object. There's no life there. It's too hot. It's still forming the beginning molecules. And between 3 billion and 5 billion is the window, I would say. Because that's when there's enough liquid water there. That's when the atmosphere is just thin enough, it's not too pressurized. That's when it can protect the life that does form there. And then as the magnetic field dies, the life dies. And since there's no magnetic field on Venus, here's a little timeline. Here's the too hot stage. This is the just right stage. and here's where the star dies and there's no life there. This is where Venus is. Earth is around here, Venus is around here, meaning it's much older. As well, there's no water oceans. Water oceans don't form, just like life. Water oceans don't form in the very beginning. It takes a lot of time for the star to cool and die. Eventually, there's a window of opportunity for water oceans. I'd give that maybe 1.5 billion years, between 3.5 to 5 billion. And then once the water oceans evaporate, just like they are in Venus, because the magnetic field dies, there's no way for life to be there. It will be a completely sterilized, inhospitable world. But basically, this kind of understanding doesn't exist in establishment. That's why I'm going ahead and explaining it to my readers, to my listeners. There are two windows of opportunity that go hand in hand: the water ocean and the life formation. And Venus is well beyond that. And we know it's well beyond that because it's not in the beginning stages. Clearly, it's not a gas giant or a sun-like star. And it's about the same size as Earth, which means it was probably very, very, very much like Earth, with people just like us wandering around on the surface many millions of years in its past. But there's no life there now. It's a dead star, basically, and we can move on. So I guess you're wondering, the reason why I wanted to address this is because a lot of people that I've come across online, you know, I'm open to new ideas, but the idea that somehow Venus came from Jupiter 6,000 years ago, or 10,000 years ago, or 20,000 years ago as an ejecta or something, that doesn't work at all in this theory. You can keep that, that's fine, but it doesn't coincide with this theory at all, and this theory doesn't even coincide with what establishment says is true. So just keep that in mind. There's 3 different ways of looking at it. In this theory, there's no way Venus can come out of Jupiter, and there's no way Venus is only 6,000 to 20,000 years old. No way in hell. Because of all these things that I've noticed about basically observing it and putting all the pieces of the puzzle together. So, unfortunately, that's basically that in a nutshell. I'm sure there's more. Those are the generals of it. Alright, y'all, take it easy.